Hi guys, this is Professor Vishal Jagtap from Department of Electronics and Telecommunication Engineering. Today we check what is electrical circuits and networks. What is electrical circuits and networks? Electricity. Electricity is a great invention of human being on the earth. Electricity has brought our lives from darkness to the light. Electricity has become an essential thing, just like food, clothes, air and shelter for us in our day-to-day life. So let's check the role of electricity in our daily life. In that picture, some examples are shown where we are utilizing the electricity, where it requires the electricity, and these all are the essential things in our life. So let's check what exactly the electricity. The journey of electricity. The journey of electricity is always start from generation to the customer. So in between the generation and customer, there are two important phases, that is called as a transmission and distribution. So roughly we say that the journey of electricity having the three important sections. The first one is generation, transmission and distribution, and then it reaches to the customer. So these three important sections of electricity forms the electrical circuits and networks, and that is the today's topic of discussion, electrical circuits and networks. First we check some overviews. So what is electrical circuits? The electrical circuits is the interconnection of various electrical components in a predefined manner to form the closed path, and this is called as an electrical circuit. So closed path is the most important thing. Whenever we are connecting the electrical components in closed manner, it forms the electrical circuit. So here it is, some basic diagram of electrical circuits are there. So in that diagram, the battery is there, this is a source, switch is there to on and off, and here it is the bulb. Electrical networks. And electrical networks is a connection of two or more simple circuit elements and may not be a necessary be a circuit. So what exactly the conclusion that when we have a number of electrical circuits and if we combine together, it forms the electrical networks. So it can be referred as large electricity distribution or transmission network. So here it is some example or some basic diagram of network. So what it shows, it again shows that number of circuits are connected together. So before going to discuss the electrical circuits and network, some prerequisite we required. And what the prerequisite? The prerequisite is started from electrical charge. So basically the charge is the fundamental quantity of electricity, is a most fundamental quantity, as we shows in a diagram. Here it is at the center, this is a nucleus, protons, and here it is the electrons. So what exactly the protons? So protons are positively charged particles, so it has a positive electric charge. What electrons has? The electrons has negatively charged. So these electrons are always revolving around the nucleus, and protons and neutrons, the neutrons which having no charge, it is situated at the center, and the center is called as a nucleus. Next we check the next parameter, that is called as the electric current. So electric current is the movement of charged particle in a specific direction. So as we observe in the diagram, here it is, this is a conductor, the conductor having the two terminal from A to B, and this red dot shows the path of electric current. So current is always flows from positive to negative, so it shows a flow of conventional current direction. It shows a flow of conventional current direction. So what exactly the basic definition of electric current is the time rate of change of charge. It is the time rate of change of charge. The symbol used for current is capital I, and the unit of this is ampere. Next we check the another basic quantity, that is called as a potential difference. or simply it is called as voltage. So to move the electrons in a conductor in a particular direction requires some work or energy transfer. So basically what we are showing in both the diagrams, here it is we are using some battery. Here it is a 1.5 volt battery and here it is a 6 volt battery. So 1.5 volt and 6 volt is the example of potential difference. This is an example of voltage, and this voltage always creates the electric current in the circuit. So that's why the potential difference is basically called as a EMF. Next we check the resistance. So resistance basically is the property of substance to resist the flow of current through it, and that is called as electricity. So what we observe in the diagram, here it is, the diagram is self-explanatory. Whenever we are applying the voltage between 2 points in the closed loop circuit, the current start to flow, but opposition to flow of current is the property of substance or conductor, and this property is called as a resistance. So let's we recap some points. So electricity is a undividable part of human being. Second point, the journey of electricity is divided into the 3 sections: generation, transmission, distribution. Electrical circuit is a closed path which contains electrical components. Combination of electrical circuit forms the electrical circuit. Charge is the fundamental quantity, positively charged and negatively charged. Means what? The positive charge is called as a protons and negative charge is called as a electron. The electric current is the rate of change of charge. Potential difference is the path in a potential difference is the difference in potential between 2 points in an electrical circuit. The property of substance to resist the flow of electric current through it, that is called as a resistance. So for more detail, contact us related to these topics. Thank you.